Hi students, welcome back to my channel Electronics Express. Today in this video, let us learn about what is meant by mutual inductance and its applications. Now moving on to the topic, first let us see how we can define the mutual inductance. The EMF induced due to the magnetic field in one coil which opposes the change of current and the voltage in the other coil is defined as the mutual inductance. So if you see here, this is the coil 1 and this is the coil 2. Now when the two coils are brought in proximity with each other, then the magnetic field in one of the coil tend to link with the other coil. And this leads to the generation of an voltage in the second coil. So this is the second coil. And in this second coil, due to the linking of the coils, a voltage is generated. And this property of the coil which affects or changes the current and voltage in the secondary coil is called as the mutual inductance. So this is how we can define the mutual inductance. Now let us see how we can define the coupling coefficient of the mutual inductance. The fraction of magnetic flux linked with the two coils to the total magnetic flux between the coils is known as the coupling coefficient and it is denoted by the letter K. And the coupling coefficient specifies the inductance of an inductor. Now let us see the formula for the coupling coefficient. The coupling coefficient is represented by the formula as M is equal to K into root of L1 into L2. And the point to be noted is, if the value of K is equal to 1, then the two coils are coupled perfectly. Whereas if the value of K is greater than 0.5, then the two coils are coupled tightly. And if the value of K is less than 0.5, then the two coils are coupled loosely. So this is how we can calculate the value of the coupling coefficient which specifies the inductance of an inductor. Now let us see what are the applications of the mutual inductance. The first application is the transformer. So if you see here, this is the transformer which makes use of this mutual inductance. The next one is the electric motors. The third one is the generators. The fourth one is the electrical devices which work with a magnetic field. The fifth one is these mutual inductance can be used in the calculation of eddy currents and they can also be used in the digital signal processing. So these are some of the important applications of the mutual inductance. Now let us solve a problem related to the mutual inductance. The question is, two inductors whose self-inductances are given as 75 millihenry and 55 millihenry respectively are positioned next to each other on a common magnetic core so that 75% of the lines of flux from the first coil are cutting the second coil. Then calculate the total mutual inductance that exists between the two coils. This is the question. Now let us see the solution. So earlier we have seen the formula for the mutual inductance as M is equal to K into root of L1 into L2. Now by substituting the given values we get M is equal to 0.75 into root of 75 millihenry into 55 millihenry. So finally we get the value of the total mutual inductance as M is equal to 48.2 millihenry. So this is how we can calculate the problems related to the mutual inductance by using its mutual inductance formula. Now let us see the question of the day. The question is, mutual inductance between two magnetically coupled coils depends on, the first option is permeability of the core material. Second option is number of turns of the coils. The third option is cross-sectional area of their common core. And the last option is all of the above. So if you know the answer, comment me the answer in the comment box. So this is the end of the video. Hope you like this video and understand the concept of what is the importance of the mutual inductance and what are its applications. So if you like this video, please do like, share and subscribe to my channel Electronics Express. Don't forget to click the bell icon. Please subscribe to my channel.